Question 11. What kind of charge does a proton have, and what kind of charge does a neutron have? Answer. A proton has positive charge of 1, that is, equal but opposite to the charge of an electron. A neutron, like the name implies, is neutral with no net charge. The charge is believed to be from the charge of the quarks that make up the nucleons, protons and neutrons. A proton is made of 2 up quarks, with 2/3 positive charge each and 1 down quark with a negative 1/3 charge. 2/3 plus 2/3 plus minus 1/3 equals 1. A neutron is made up of 2 down quarks with a negative 1/3 charge each and 1 up quark with a positive 2/3 charge. Minus 1/3 plus minus 1/3 plus 2/3 equals 0. Question 12. Why do protons and neutrons stay together in the nucleus? Answer. The nucleus of an atom is held together by the strong nuclear force that binds together protons and neutrons. Although the strong nuclear force is the strongest of the 4 fundamental forces, it acts only over very short, typically nuclear, distances. It binds together the protons and neutrons in the nucleus. It also holds together the quarks that make up those protons and neutrons and the other hadrons. Question 13. How many times bigger is a proton than an electron? Answer. It depends on what you mean by bigger. A proton is about 1835 times more massive than an electron. If you are asking about their physical dimensions, no one knows. Scientists currently do not know how small electrons are. They are smaller than we can currently measure and may not have a size at all. Question 14. Why are electrons so far away from the nucleus of an atom? Answer. Electrons are indeed far away from the nucleus. If we could magnify the simplest hydrogen atom so that its nucleus, a proton, were the size of a basketball, then its lone electron would be found about 2 miles away. All of the space in between the electron and the basketball-sized nucleus is empty. But why the electron is so far from the nucleus is no more mysterious than some of your everyday experiences. Imagine that you tied a baseball to the end of a long rubber band. You hold the other end of the rubber band in your hand and start swinging the ball around in a circle. The faster the ball goes, the more the rubber band stretches and the farther away is the baseball. In an atom, an electron is attracted to the nucleus by the electromagnetic force, similar to your rubber band. Question 15. If atoms are 99.99999999999% empty space, then why don't things pass right through them? Answer. Things don't fall through other things because they are levitating on an electrostatic field. I am not kidding. When you sit on a chair, you are not really touching it. You see, every atom is surrounded by a shell of electrons. This electron cloud presents a rather negative face to the world. Remember that like charges repel each other. When two atoms approach each other, their electron shells push back at each other, despite the fact that each atom's net charge is 0. This is a very useful feature of nature. It makes our lives a lot easier. Question 16. How fast do electrons move? Answer. As fast as you can get them going. Well, not quite. One of the facts of life discovered in the 20th century is that the speed of light, 3 lakh kilometers per second, is the ultimate speed limit. As you add energy to the electron, it will go faster, but as you get it to go close to the speed of light, you find that you have to add even more energy just to bump it a bit faster. For example, with just over 2,20,000 electron volts, which stands for a convenient unit of energy called the electron volt, you can get the electron up to 90% of the speed of light. But to get it to 99.9%, just another 9.9%, you need a total of over 11 million electron volt. One way of looking at this is that the electron gets heavier, more massive as it goes ever faster, so it's harder to push it faster. Question 17. What do we use to measure mass? Answer. The difference between mass and weight causes a lot of confusion amongst a lot of people. Put simply, weight is a measure of gravity's effect on something. Mass is the amount of matter in an object. Move to a different planet and an object's weight will change, but its mass will be the same. There are a couple of ways to measure mass. The most common method is to use a balance. Hey, wait a minute, you should be saying, people weigh stuff all the time with a balance. Think about about it. If you go to a different planet, the balance weights change by the same factor as the object you are measuring. Your mass measured with a balance would be the same on the moon as it is on Earth. There are a couple of other neat tricks, but they only really work perfectly in no gravity, no friction environments. Question 18. If everything around us is matter, what about germs? Answer: yes, germs are matter. The definition of matter is something that has mass and occupies space. Germs certainly meet that criteria. Of course, germs are tiny and impossible to see without some tool to amplify our senses, but they are huge compared to the atoms that make up those germs. Those atoms are also matter and are even smaller and harder to see than germs. About the only place you can be where you aren't completely surrounded by matter is in space, and even there is some matter, just not nearly as much as here on Earth. You wouldn't really like it there though, because without all that nice matter, remember air is matter also, pushing on your body, you would be uncomfortable. Okay, you'd pop, but I would call that being pretty uncomfortable. Question 19. Why is matter not being created at the present time, nor being destroyed? Answer: matter is being created and destroyed now. For example, a high-energy X-ray can collide with the nucleus of an atom and disappear in two particles. An electron and an anti-electron, aka positron, will appear in its place, so extra matter is being produced from no matter. The important thing is that the amount of total energy stays the same, but the energy can change its form from electromagnetic radiation, the X-ray, to matter, the electron and positron. Also, an electron and positron can collide with and annihilate each other, producing X-rays. Question 20. What is plasma? Answer: plasma is the fourth state of matter. Many places teach that there are three states of matter: solid, liquid, and gas, but there are actually four. The fourth is plasma. To put it very simply, a plasma is an ionized gas, a gas into which sufficient energy is provided to free electrons from atoms or molecules and to allow both species, ions and electrons, to coexist. The funny thing about that is that as far as we know, plasmas are the most common state of matter in the universe. They are even common here on Earth. A plasma is a gas that has been energized to the point that some of the electrons break free from, but travel with, their nucleus. Gases can become plasmas in several ways, but all include pumping the gas with energy. A spark in a gas will create a plasma. A hot gas passing through a big spark will turn the gas stream into a plasma that can be useful. Plasma torches like that are used in industry to cut metals. The biggest chunk of plasma you will see is that dear friend to all of us, the sun. The sun's enormous heat strips electrons off the hydrogen and helium molecules that make up the sun. Essentially, the sun, like most stars, is a great big ball of plasma.